Dyneema, I ordered a Dyneema without a sheath because it's the best rating between diameter and strength. And special forces use Dyneema with 4 millimeters by now. This is in some areas. So this is 35 meters plus 5 meters for slings. And then I read about your record about some kilometers or miles across big valleys, and that you have a little string, a P-cord, where you pull up a rappel rope. Is that true?
Yes.
And I don't know how thick it is, but I thought, why not rappel down this line? And then I started with this. This is 15 meters of 3 millimeters. And so this is 30 meters of 3 millimeter. Maybe you could even go down, but now I did test with 3 millimeters and started some tests, and I thought, how close to the failure I am. And I used my lab and to explore a little bit. And now I would like to ask to play the video.
I hope you can hear the video online. I'm not sure. Let's see.
Das ist für mein Gewicht genug.
Can't hear it. Anyway.
Und den doppelten Halbmastwurf. Wirklich zum Handeln. Der Karabiner hält 6 Kilonewton aus. Das ist für mein Gewicht genug. Und da mache ich jetzt den einfachen und den doppelten Halbmastwurf. Und mit dem kann ich mich abseilen. Wie man sieht, kann ich das Seil bequem mit 2 Fingern halten. Sehr gemütlich.
Okay, well.
So I can talk again. I hope you identified everything in the video. The idea was I let the Munter hitch work against 80 kilogram weight. And if you pull it back and forth on a distance of half a meter, then it's really, really a heavy impact. And so this is not, can I only rappel down 20 meters or something and then the rope will break? It was for comparison reasons. So I know that I can rappel with a red line forever. I know that I can rappel with a climbing rope, obviously. So I wanted to compare those ropes. And now, please, the number of cycles. Yes. So one important question was, do I see when the lifetime of my rope or line ends? And I can say clearly, yes. When you look on a heavy worn Dyneema, then it's stiff, like a stiff wire. So it's easy to identify when it's just before breaking. This was important.
I would disagree on this. The stiffness does not come from abrasion. It does not come from aging. It just comes from tension. If you put Dyneema rope under higher tension, the fibers align really well because there's nearly zero friction within them, and that leads to the stiffness in the rope. You see this in every new rope. If you put it like to 200 or 300 kilograms, they become this stiff. And but there's indicators for abrasion in Dyneema ropes from rope companies, so you can see when a Dyneema rope is done.
Did you hear everybody? That was it? Yes. Before I go into these details, for me it was important, does it look like new before it breaks? Or can I see when the abrasion gets heavier and heavier and heavier and then it breaks? And the answer is, fortunately, you can see it. It's not, it's brand new, and bam, then it snaps like some webbings do, where you cannot really see it very clearly. In these lines, you can see it very clearly. Then the next question was now the comparison. Can you please, on next slide? We had these 5 lines. The 3 millimeter, 4 millimeter, the red line, the 10 millimeter climbing rope, and the 11.5 millimeter, which is not in use nowadays. I had an old one. That was the last was the 11.5 millimeter climbing rope. So you can take 10 seconds to think what was the weakest, what was the strongest. 9, 10, and now comes a solution. So the red line was the weakest, 20 cycles till breaking. The temperature goes up very, very quickly in these cyclic back and forth against 80 kilograms. Within 5 cycles, it's around 100 degrees centigrade. The 3 millimeter Dyneema was a little bit better. The 10 millimeter climbing rope was then much better, at least double like the red line and the 3 millimeter. And the 4 millimeter Dyneema was even better. So this was quite surprising to me. I explain it because it's so smooth. It has no sheath with friction. The red line has a sheath with polyamide and I think some background, I don't know, a mixture. And the temperature of the sheath goes up due to the friction. And the 4 millimeter is very smooth. You can really see it, how it slides. And even when you pull it down from rappelling, it goes through trees and wood and everything zip, very easily. If it's new.
did you also try, because when I saw the video, you are rappelling with double or triple cleavage. Did you try the double or triple one with your machine?
Yeah.
Can you repeat the question?
So the question was, rappelling down in the Alps is done with double rope because you want to get it down.
No, not double rope.
And
double munter hitch.
Double munter hitch, sorry.
Yes, double the munter hitch on the Dyneema lines. Otherwise, you won't have enough friction to.
Yeah. So that you need to, with a single munter hitch, if I understood your question right, you would fall down. I cannot even hold my weight.
But he's asking if he tested that scenario as well, or just a single.
I tested only the single because with a double it wouldn't work. It would pull up the weight, and it would.
So it can't go.
So it cannot go round to the other side. It would pull up, and then the weight would fall down suddenly. So it doesn't work.
I'm saying that we cannot compare the number of cycles of the 10 and 11.5 millimeter ropes, but only need a simple cleavage with the Dyneema that needs a double or triple one, because in the reality you are not using the same knot.
That's a good point.
Yeah, for me it was important just to have. I'm on the beginning of this research, and for me it was just to know how close am I to dying when I use a 4 millimeter or a 3 millimeter with braking. I would suggest that if you use the double munter hitch and go slow, that you have a longer lifespan of your rope. But I don't know. I'm evidence-based. For me, the interesting thing was 11.5 millimeter climbing rope didn't break at all. It got stuck. It got completely stuck, and then it was just pulled up and down the weight, and nothing happened. So for me, actually, that's all for my presentation. I'm at the beginning, but I think that it could be a good idea to have a very thin line, which you need to get a rope up anyway. If you would be able to rappel down, why not?
Maybe Liam has an online question here.
Liam?
Hello. Whoa. Hello. I mean, as a backup of a backup, I would for sure be a bit sketched out, starting to rappel of a highline on a 4 mil rope. I have some questions of the testing. So going back and forth, especially as you mentioned, since some ropes have some abrasion and some others, like the Dyneema, don't have so much abrasion. So going back and forth and having the knot flip, that seems quite different to just continuously rappelling, and it also disperses the abrasion onto more rope. So I'm not sure like how representative. I know it's an initial test and a concept proof, but how will that translate to just going in one direction all the time? And there, another concern for me is how hot will it get, so that maybe it's not abrasion breaking the Dyneema, but just the temperature melting it, since Dyneema has a way lower melting point. And then, like, I'm very curious of like a friction knot in Dyneema. That's a strange concept in my head. And what about the attachment to the line itself? Like, do you splice it? Do you have a knot in Dyneema? I'm guessing not. And how much the munter hitch reduces the strength of the Dyneema? Have you done a MBS pull on it?
A lot of questions. Yes, I did tests with normal knots, and they just work. With a figure 8 or a figure 9 knot, it was strong enough to hold your weight, plus margin, plus safety factor. To my
safety factor?
surprise, but those lines are very easy to splice. So even for me, I'm not a splicer. It's very easy to splice.
Clip it to the leash ring,
What?
for example. You could just clip this with a carabiner to the
Yeah,
leash ring.
carabiner, leash ring, and it's done. Or you really can tie a knot. It's strong enough to hold your weight. I'm talking about emergency, not about you go home every evening and rappel down 100 meters with a 3 millimeter and always with the same. That's not what I'm talking about. I'm talking about the once in your lifetime emergency on a 10 kilometers slack line. The second is don't make the mistake to take standardized tests to reality. Like the climbing rope test happens never in reality, and people make often the mistake. This rope holds only five falls. So after the fourth fall, I'm in life danger. That's completely stupid, and you just identify yourself as I have no idea about testing and standards. Standards are created for two reasons. First, to compare different products or the same products if they are really the same, and to make sure that for the whole lifetime of your use, they are fit for use and that they are safe. Nothing else. And they not necessarily should match or mirror the reality. So, and my tests were not designed to mirror reality at all. They were designed, I know that I can rappel down with a red line, which is quite thin for many people. If you talk to the industrial climbers here, then they freak out if you see a 6 millimeter line. I'm doing my whole XS work since 6 years only with a red line, and it works perfect with everything. So I know this works. And now I try to find a way to compare other than having 1 year rappelling down a rope. And this is, I made an impact which is so hard that within 1 day I can compare 4 lines. There was one other question with a Munter hitch or what?
Yeah, like maybe the temperature.
The temperature, yeah. For me, I rappelled down a lot with double Dyneema rope and also with single strand for 10 meters, and that was no problem. But this is something that has to be done.
Is the carabiner getting hot?
The carabiner gets hot, but I couldn't get it so hot. And when you saw in the beginning of the tests, I tested different speed, and double speed is half lifetime. So I wouldn't recommend to go down as fast as possible, 100 meters. But we don't know, maybe it works. I don't really know, because the heat is transferred always to a new piece of line, and the heat is transferred away from the carabiner. Not here. The whole line gets hot immediately within 5 cycles. You can see that you can smell it, that it gets hot. But when you rappel down, pardon me?
You can't stop once your carabiner is hot. Then you might have a problem.
Yeah.
So on this, like, I'm just going to come over here
Yeah.
to the team. So what we do in the German mountain rescue team, like we use the Dyneema ropes. They have 8 millimeters. We rappel with 400 kilograms and 400 meters in one go, and it's no problem. Like you do the double, I don't know the English name. Montage.
Motor.
And we even stop. You take it off like it's steel carabiners, so they don't even disperse the heat away from the knot. This is not a problem, but take this with a grain of salt. It's 8 millimeter for what we use, but like we had no issues with that. Like a Dyneema, like he used like without a
Similar to this
like
one.
8 millimeters, and we use 2 of them like simultaneously, but it's only one that's always loaded because you can't like maneuver it like good enough. And we like it's allowed to have 400 kilograms on the plate that you rappel, like 2 rescuers plus gear plus someone that you take on, and like we do 400 meters in one set. Like you go down 400 meters. Of course, like you try to not kill anyone, and the main reason you go slower is you would naturally like kick off rocks, especially if you go like if you think about you rescue someone from a climbing from a multi-pitch climb, so you fly with a helicopter to the top, you start like bolting an anchor, and then you go straight down. So you might go through territory that no climbing route was going through, so it's loose rocks everywhere. So that's the main thing. Like you try to go slower in order to have like time to maneuver. But so far, I don't know if we did like any calibrated speed tests, which would be like hard to do.
I have a question concerning exactly what you already mentioned. You're using steel carabiners. I think you used aluminum carabiners. I think this comparison would be interesting to test. Steel carabiners concentrate the heat. Aluminum carabiners get hot. So one says, yeah, the heat goes away, but this can be positive or negative. I think just that the comparison, maybe there's other materials that are a bit more specific for such use, which I cannot think of right now, but maybe special carabiners with some special material. That's just an interesting kind of thought to build into some experiments, to have some different metal parts there too.
Before I'm doing this, I would like to find out if heat is really an issue. I don't have the courage, but I would like to rappel down on this line quickly, 30 meters, and then stop. I need additional backup system, but that's quite an effort in my lab. It's easier. So I don't think we have an issue with heat. That's only my assumption. But I don't know. I'm evidence-based researcher.
I think there have been some tests in. I think there have been some tests of carabiners on Dyneema rope, but I think it was 6 millimeter rope for taking off planes, Segelflieger. What's the English term? Gliding planes. They back then they had steel cables to pull them up. Now they use Dyneema ropes to pull them up, and I think they tested the heat that's created in carabiners that are before the winch that pulls in the rope. And I think, if I remember correctly, they also found that they cannot create enough heat in a carabiner running the rope around it that the Dyneema rope melts.
Yes, they did, and they also did some tests at Pretzel. The heat caused by the friction in between Dyneema and metallic stuff is not impacting.
Yeah.
But on the plain, let's say the big bobbin pull, they had a lot of troubles. I'm working with a company manufacturing ropes about it, and they dismissed within the last years the producers the Dyneema because of that, because inside of the bobbin of the winch, the heat is getting accumulated, and they have the heat problem inside of the winch, but not onto the connection and not onto the friction points.
So I recommend that slackliners shouldn't use winches. So I have just a question. How thin was the line which you took on your record?
It was 2.5 millimeter, but we need to have 150 meters of it. So like 4 millimeter would be a lot.
Yeah, 4 millimeters is for special forces, 100 kilo guys and so on. But they have enough margin, but I'm working now with 3 millimeters and you work with 2.5 millimeters. I think that with material, maybe that Vectran, for example, would be better than Dyneema, but I don't know. So this is something, I'm pretty sure that 2.5 millimeters would be strong enough to rappel down,
Yeah,
but I don't know yet.
Like you need how do you hold the line?
Huh?
How do you hold it? You have the
Triple, I would use a triple Munter hitch, most probably with a 2 millimeters. And I could hold a double Munter with double 4 millimeter very easy. With one single strand, we can try it out afterwards. I can hold it with one hand with triple Munter hitch. But I'm 60 kilos, so it depends on the body weight, maybe too. But that's something each of you can try out, but don't try at home.
Okay, we got. Yeah,
Yeah, just quick question. Since rappelling off the end of your rope is one of the bigger risks, and Dyneema is notoriously bad at knots and they slip, have you tested a little bit what to do with ends of rope? So you just do a stopper and it works those forces. You are muted.
Sorry. I personally would tie it to the bag, and the bag cannot slip through the Munter hitch. And knots are not that bad. So I can, I will publish some tests. I did it, I cannot remember the breaking load, but I was surprised because everybody says ropes are life dangerous, but they had.
But more in shock
length.
than in slow pull, no? It's more of an issue in shock loading than, yes.
It is due to shock, and also there is a huge difference in between a brand new Dyneema rope and a used Dyneema rope with the friction, because we know that Dyneema is very slippery, but it's even more slippery due to the lubrication that they use to make the braid.
Coating.
Manufacture the braid.
Can you maybe repeat so the people online
Yeah.
understood what he just said?
Am I on? He's too much. First, it depends if it's new or used. The strength of a knot. It in the new when it's new, it's coated by some lubrication that it gets slippery. And will it hold better or less good when it's new?
It's slippery. It's much more slippery inside the knots when it's brand new than when it's.
Yeah, but
So if you want to make some knots on an old Dyneema rope, most of the time, if it's used in static, you have no problem.
So used in static with old Dyneema, you have no problem. I found out with my 4 millimeter that I have no problem with the brand new one. So it's still strong enough. The question is when it gets dynamic, how does it work with knots? I don't know, but what are we talking about? We're not talking about lead climbing with 3 millimeter Dyneema. We're talking about once in a lifetime emergency from a 10-kilometer long line where you
That will absorb the shock.
And that would absorb the shock anyway. So, and holding the Munter hitch absorbs every shock also. So we always have to put in consideration what's the purpose of the whole thing. It's a single event in emergency.
Let's see. Can this be seen? Can you hear me? Can anybody hear me? Excuse me? Okay. Let me start this slideshow. Okay. So hello, my name is Hai Tai. I am the current president of the ISA Safety Commission. I'm going to have a quick talk about the gear standards, just a little update and maybe the status of the standards as they currently are. For anybody that doesn't know, the ISA gear standards are a set of standards and certifications for slackline, highline specific gear. Let's dig into it. We'll talk quickly about some new certified gear and potential gear that's coming in the pipeline to be certified. Updates to our standards from this past year, potential standards and future work on standards, and then ideas for expansion. This past year, we had a new certified connector, Slacktivity Kingpin. This is from a new standard for Highline connectors. So this was the first piece of gear in the Highline connector to be certified as a Highline connector. We're waiting for quite a few webbings to be completely certified from RAID, but this will represent quite an increase to the number of certified webbings available to the community. In the pipeline, we have potentially quite a few items from North American slackline company, Balance Community, getting certified. So this likely includes webbing and hardware as well, and probably a web lock. Some updates that have happened in this past year. Maybe I'll talk about updates generally. 2023 was a big year for changes in our Highline system and Highline webbing standards. In 2023 last year, we made a big push to add fractionated Highline systems, so connections in webbing, and also dedicated backups. This represented quite a change to the standard. This past year, the standards in general have been much more stable. So the Highline system, now we added anchor access system to the Highline system. So this is just a definition of ways to get to the anchor safely as part of the safe Highline system. The big change this year has been new lifetime recommendations, which came as a result of the CRG incident. Previously, I think we have it on this page. Previously, we had recommendations for ultra low stretch webbings made of Dyneema, and then other recommendations, and also recommendations for other high-tech webbings. Given that the accident that has happened with likely due to advanced weathering or weathering, we basically do not have enough information to have a recommendation. So we've removed our recommendation for Dyneema webbings, and then also other high-tech webbings we don't have quite enough information for to have any kind of lifetime recommendation. The manufacturer, of course, can give recommendations for their individual webbings. We are hoping to conduct tests on Dyneema webbings for UV exposure and weathering. Once we have more information, then we can potentially have recommendation in moving forward into the future with regards to lifetime. I think we have also shortened our lifetime recommendations for polyester and polyamide. We made some small changes to that as well. Let's see. So new standards, new changes. So the ISA sling standard, the Highline sling standard was finished last year. I think potentially this year we might have certified slings coming. Once that's done, we'll have Highline systems that can be certified end-to-end, basically. Updates for the Highline connector, as I said before, the Slacktivity Kingpin is their first product that's been certified. I think, yeah. Okay, in dev, we have trick line system standard, defining everything in a trick line system. That's still under active development. The status of the starter kit standard never really got off the ground because of DIN. I don't think we'll be putting too much work in it in this coming year. And as I stated before, we need more data for lifetime recommendations on high-tech webbings. Some thoughts and goals. We had previously a goal to get leashes from all manufacturers, all major manufacturers certified. That's still a goal. I think if we can get a bit more manpower, human power in the SafeCom this year, we can really push to get that goal done. I think it's a pretty reasonable goal, and it's certainly one of the most apparent things that a Highliner will tie into, of course. Our other goal would be to get more certified gear across all continents. Right now, it's mostly Europe that has certified gear. In the Americas, might soon have webbing and maybe hardware from North America getting certified. It'd be nice to find labs in South America to help facilitate this goal as well. And of course, if we have more SafeCom members, we can get more work done with regards to these standards. Okay, here's some links and resources. That is the quick update. I'll open up the chat for questions.
Yeah, I have one question. Why exactly prevents the Dean of Slacklines to create a standard for starter kits?
Thomas, could you answer?
No, Tom can speak.
Okay, sorry. I also texted you, Thomas, about this some days ago. Maybe we can have an open discussion about making the Highline standards mandatory for all manufacturers. What we're seeing right now is that several manufacturers take the cost of certifying gear up to these standards, and some manufacturers avoiding these costs. And this might lead in the future to some kind of disbalances, so that certain manufacturers may be, when avoiding costs, trying to sell slackline gear cheaper than others because of avoiding costs. So I think we should have a discussion about how can we get these standards to become mandatory for all manufacturers to level the playing field. I think we talked about this 1 year or 2 years ago already, and I would like to bring this up again to just have an open discussion about this. Yeah.
So we have Hello. No, it's not over argument. We are trying to certify some few products, but the fact that we do not certify all of our products is just cost related. That's all. Because in our company at least, but I guess for most of the slackline companies the same. The cost, how to say, the sustainability of our business is really sensitive to the cost prices, and we just selected some few products that are really important, in our opinion, to get certified, to get some extra credibility and some extra safety to offer to the customer. But yes, we weren't able, when doing the sustainability calculation, to certify all of our gear. That's all. I hope in the future maybe it will be possible, but not yet. Another point is, maybe I am wrong, but I feel that compared to a standard like we have on climbing gear or whatever, there is a question of responsibility in case of a juridic responsibility that is covered by the what's the name? The standard. the laboratory or the organism that is validating the standard is taking in charge the juridic responsibility in case of an accident or incident on the gear. With the ISA, the juridic responsibility is not taken in charge from the manufacturers. So the manufacturers still have this responsibility. And I think this can be a very big argument to get some more products certified if we can just release the responsibility to ISI. I'm not meaning that I just want to wash my hands with that, but it's something that can be considered.
Like to, I'd like to add some thoughts to the first point, the point of cost. If we can find in the near future an agreement among all manufacturers and resellers to agree that everyone certifies their gear, then every manufacturer bears these costs. Every manufacturer has to calculate these costs in the prices of their products, and we have a level playing field. What we have right now is that some manufacturers opt in to certify their gear. They bear these costs, so they have to sell their gear more expensive, and other manufacturers opt to sell their gear cheaper because they don't certify it.
Mm-hmm.
This is not a level playing field.
I know, but still it's a label and not a standard. This is legally not possible, I guess.
No. You're wrong.
Okay, so Thomas might add something to the legal options of this.
Yeah, I think I have bad news for you. The liability system within the EU, I don't know in Switzerland, is that if the customer has a damage, that's a product liability system. I'm not a legal person, but I had a case where the customer could choose whom to sue. The whole line between the person who brings it into Inverkehr bringen,
To the market.
brings it to the market. That's a beginner, and then the whole line, import, export, and so on, can be sued. So I think you cannot just let somebody make the certification and this body has a liability, as I know, because we had a legal case in the Robscos industry.
Can you, I didn't understand. Can you rephrase it for me?
So you cannot give me the legal load.
Yeah. Okay.
Period.
Because they can choose.
They can choose you or me. But mostly you.
Can choose.
Is it
According to EU law.
Yes, I guess when we pay for the UEA label or I don't remember, but
Ian?
the EN, yes, I am giving the responsibility to the laboratory.
Maybe you can add Philip to this, because
Yes.
I think he has a lot to say about this.
Yeah. Okay. Maybe maybe you can share your thoughts on the whole league. I know that we're not legal experts and we're going into the territory which is never going well because it's very broad. But maybe first clear, and you are to you I information. And the question that came up from one of the slackline manufacturers was once he tests with one of our independent laboratories after our standards, where does the legal responsibility fall? It's a very general question. It's not that easy to answer, but maybe first payment and maybe people can give us some insights on this question.
Yeah, so there is no legal responsibility for the product by any test facility, laboratory, or notified body. And the manufacturers also normally has the legal responsibility for their products. That's in the PPE regulation for European climbing products, for example, and also the general product directive that will be relevant for slacklining products within Europe. The responsibility is always on the manufacturer and to some extent to the importer and so on, but not on the laboratory. Of course, if the laboratory does not something incorrect, but that's another type of responsibility. That's not a single product responsibility.
Yeah, and just to add, so yeah, it's on the manufacturer, as Siebert said, and in the case of the UIAA, recently our insurance wanted to increase our cost like in a crazy way, because they were thinking that we are kind of responsible if there is that we would be attacked if there is a problem. But yeah, in the end, it's really the manufacturer who bears it.
Okay, it seems like there could also be a legal safety if a manufacturer can do their due diligence. Sure, they can still be sued, but they can show through the standard that they have tried to independently certify to. Talking about costs, we are very aware of the financial load of these tests. I think in creating the standards, we try and make it so that the independent testing is thorough and relatively easy to do for a lab to reduce the costs of these standards, while still covering everything that needs to be covered. With that in mind, I think like the ISA really has no ability to levy fines against manufacturers or anything of this sort. So like in terms of ways we could enforce applying the standards to all gears or having all manufacturers certify their gear, there's no real enforcement mechanism. So rather than any kind of levying of fines or anything like that, we could potentially make it more beneficial for manufacturers to levy gear. This can be forms of outreach, using the ISA's social media potentially to highlight gear. This is something that to highlight certified gear in particular. This is something that the Safety Commission has been considering for a while, just to increase uptake of standardized gear or certified gear. But up till now, not something that we've really decided to put effort into. Yep.
Thanks, Highlight. Yes, it's a very sensitive subject. I just wanted to make it clear about the legal responsibility. I was talking about it because as a manufacturer, we are paying a lot of insurance about to be covered in case of accident. And in the past, because nowadays I'm not the one dealing with the insurance, but when I was dealing with the insurance for Slakinov, I knew that I was a lot, and there were my insurance partner said, and many of those said to me, if there is a standard, at those ages nothing was existing, even the ISA one. But if there is a standard, it would have been easier for us and cheaper to certify than without the standard. And I know that with the actual ISA certification, it's Eduardo's, another my colleague dealing with that, and he said it's still the same, that he cannot negotiate any discount, let's say like that, on the insurance thanks to the standard, and that would help us, for example, to compensate the extra price we are paying to get our product certified.
Hi, thanks for your Hello, hi, thanks for your input for pushing forward products that are certified. What we see right now is that in certain Highline communities, this doesn't matter at all. What we see is that in certain communities, people opt to choose cheaper webbing over safer webbing and over certified webbing especially. So what we see is that if we have webbings that come with kind of similar specs, certain communities just choose the cheapest they can get, even knowingly choosing weaker webbing and knowingly choosing webbings where they definitely know that the sewings might not be perfect. They save about 20 cents per meter, and they definitely go for the 20 cents knowing that they buy the worst product.
I think that we also have like huge progress to make on this. Probably you and like people that are aware, and in Europe they buy UIA certified, but we have more and more non-certified product or fake certified product on the Asian market, and I suppose that many people buy it on Temu, AliExpress, or website like that, especially like new climbers that just want a cheap thing. So on our side, I think we also have to work a lot on it. We plan to work also directly with the stores online and also shops to train their, so in the physical shop, to train their sellers about the safety label, because there are also a way of communicating about it. There are direct contact with the customers, but also on online shop, like big outdoor shop, because many people buy it through these channels. But yeah, we try to communicate for the moment, but we are far from making enough people aware of what's doing the safety commission and all the safety labels. I think, I don't know, Per, what you think about it, but
yeah, it's hard for us as well, because the UA safety label is a voluntarily label across the world, and there is big discrepancies in how often it's being used, and also big discrepancies and differences between type of product. So like for dynamic ropes, it's very, very common for the manufacturers to use the safety label, but for some other products, it's not as common. And so one manufacturer might have all their climbing ropes certified, but maybe almost none of some other product, maybe a harness or whatever. So big differences. But then, so the UIA safety label has been around since 1960, so we have some history to it. But when it comes to the Europe market, then we also have the PPE regulation for all climbing products, which is of course mandatory because it's a legislation that's with the CE mark as proof for compliance. And to some extent that helps because the standards are the same, more or less, the UIA safety label standards and the SEN standards. So I don't know how it would look on the European market if we wouldn't have the European legislation on PPE.
Right. It seems like there's some way to enforce in Europe, basically, through the PPE legislation.
Yeah, not just some way. There is authorities in every country that are obliged to seek up and do this type of job to find wrongly marked products or non-marked products or incorrect products. And there is e-taxable way to report incorrect products. But that's for the CE mark for PPE, so that doesn't apply to non-PP products. Yeah. So we can't enforce UA safety label. We can just inform that it's a good thing to have, but it's a totally different thing for personal protective equipment.
Yeah, maybe we should wrap this up so we can get to the next conversation, but I will say that just generally, both slackline manufacturers and slackliners themselves are fairly price sensitive. So the cost of the certification is a big factor. However, I think if we could get a foot in the door with every single manufacturer in maybe the form of a leash, which is a relatively inexpensive certification, is also an item which doesn't change very much as opposed to maybe like webbings and web locks. Leashes generally stay pretty much the same. If we can get leashes certified by each manufacturer, I think that would be a step in getting more gear certified by all manufacturers. Any last comments?
Yeah, just for the safety label to kind of encourage manufacturer to certify more product. We change our pricing, so now they don't pay for each label, but kind of for a batch of new labels. So we hope this measure will help to go for more and more products.
Yeah, we have also considered
how much
ways
effort
to...
would it be for the consortium of ISA and the manufacturers that are already involved in ISA certifications to make these standards CE standard?
Maybe Per can talk about it. I've never...
Can you go again, please?
I think my question... Sorry,
what's the effort to take the standards to CE?
Way, from what I recognize right now, would be to transfer the ISA standards into a CE/EN standard, right? So the question that I have is, how much effort would this be to transfer the current ISA standards into an enforceable standard?
A standard is not mandatory within European Union. So it's always the legislation that's mandatory. And without making this a long talk about different types of legislation and so on, and going into the kind of sensitive subject in which if slackline systems are PP or not. So if they are PP, then like climbing products, then it's not the standard that is mandatory, it's the regulation and actual legislation that are written, and it's already mandatory in that case, and then all of your products are illegal at the point. If it's not PP, then it's just the general product directive that applies, and that already applies. The general product directive is just about to be changed to the general product regulation. You can have standards under that, but those standards are not mandatory. But if you want to go down that road and try to develop standards within SEN, then you first need to define a little bit under what technical committee that will be. There will be sporting goods of some sort, so TC 136. So what you need to do is become members of your national standardization organizations, and then the national organization within this TC 136 will vote on if they want to start to work with slackline standards. And you can just hope that you get through that vote, otherwise your membership is not worth anything. And if then you get a vote to start the work on a SEN standard, then the standard is developed in a democratic process, but then it goes to vote, and then it might be published. So you can't just say that you want to get the ISA standards into SEN standards, because it's a democratic process that anyone can be part of that. So even if you have your will on how the standard is going to look when it's finished, and there is a lot of other people around Europe that will be part of the work, and the standard might end up being something that you from ISA doesn't like. That's, yeah, because it's no longer your standard. But firstly, become members of your national standard organization, and through that you can get information how to develop standard within sporting goods.
Oh, okay, guys. For everybody who is online, a quick update. We are struggling a bit here with machine. We will need about 15 minutes to continue with the next presentation, which is going to be on a new brake test machine that we developed here. And they're just setting everything up. Needs a bit longer than planned. So now it's almost 1 o'clock. I'd say, yeah, just to be safe, like 10 after, 15 minutes after 1 o'clock, we can definitely show you what we built here in Bern, which is going to be quite interesting for some of you maybe. So hold on and see you in 15 minutes or so.
Well, what's the result?
31.5. 31.5. You were saying 36.
I think it should have gotten about 34.
Yeah.
34, 35.
Okay, we're starting any second.
Wow. That's amazing.
Okay. Everybody, please listen up quickly. So we're continuing with the last presentation from the ISA safety event. This is gonna be a presentation by Joshua Leupold, and it's gonna be on a new brake test machine which we developed here in Bern. And I think I'm just gonna be live streaming like this. Can everybody hear Joshua? Say something quickly, Joshua.
Hello. Can you hear me?
Give us some thumbs up.
Yep, it's fine.
Perfect. Thank you. Okay, wonderful. Let's start.
So yeah, that's our brake test machine. It's like brand new. I think we just didn't even do like a handful of tests yet with it, or braking things with it. So I want to present you what the thoughts are, why we choose the system, what's special about it, and yes, I think we are like in the process for almost 2 years now already that we want to have a brake test machine. I was talking with Tom how we could do it and so on. And there are like different options. So the first straightforward option was to get something like quite similar to Walter Siebert has, like a hydraulic pump and the hydraulic cylinder. We are thinking about it. I was looking around, and then actually I got across like electromechanical cylinders. So there's like no oil involved besides lubrication. And I was doing a bit more research, talking to a lot of companies, manufacturers, if this could work in our case. And I was then in contact with one manufacturer, said like, okay, that should work for brake testing also, with like some limitations, or like you need to pay a bit of special care about certain things. The setup we have here is we have an electric motor, which is being controlled by like a frequency converter on the bottom. Quite small device, but also quite expensive compared to the motor. And with this, you can control the motor running forwards, backwards at different speeds. Everything is running on 400 volts, so like not like a normal socket, but like strong current, high voltage. And then the other part, the motor is connected to like the mechanical gearbox, which is running the cylinder in and out. So it's like basically a threaded bar, which is getting pushed in and out. Here in the front, we have connected a sledge to like a rail, because the one thing issue with like the cylinder is it needs to be perfectly being aligned. If any side forces are coming on, it can destroy like the bearings inside of the gearbox and destroys the machine. So that's like the special care we need to take. It's like perfectly in line. The whole machine is like put on 2 points, so it's like able to move in this direction relatively freely. So that's like covered, even if we are like perfectly aligned. It's if there's anything happening in this direction, there's no side forces on the shaft. The other directions, like up and down, you need to take a special care, and therefore we have like the sledge attached to this track, which keeps it like perfectly in the center, so there's nothing happening pulling sideways. Then we have like here a big screw attached, where we can attach like a medium-sized shackle, where we can then our device on it. On the other side, we have our load cell, which is also attached to a shackle to like similar structure on the other side, which is like just a fixed point. Yeah. Then on the back side, we have our frames. It's like 2 H-beams above each other, which are attached to the wall. Since everything is fixed to the wall, so we could take off like everything below, can everything go out, and it's just like hanging fixed on the wall, attached with like some big glue-in bolts to it. Yeah, that's the main thing of like structure. We have like a bit of support of the motor, just that it's like it should be fine of hanging like freely off, but we don't want to have like high leverage forces on the wall, so we support this motor a little bit. Then one thing to say here is also like we have some safety measurements. So we have like emergency shut off, 3 of them. One is like this line here. If I pull this, I don't want to pull it now because otherwise the frequency converter is making some loud noises for a while and restarting. If I pull this, it's going off. So if I'm doing any work here and the machine is running and it's like something is getting tracked or grabbed, like my hair or like my clothes, and it's pulling me somewhere and I don't reach the emergency button anymore, I can everywhere go and just pull this line. The second emergency button is like here on like the control, where I can move the machine. And the third one is behind the computer, basically, that if you're behind the computer, you can have also an emergency button. We have 2 or 3 options how to control it. 2 of them we plan to use. Like one option is like directly at the frequency converter, controlling the machine, but it's like quite not really handy being down there. So we have like this handheld control, which is connected directly to the frequency controller, which means we don't need to have the computer on. And like this, I can have like buttons going in, going out, and then I've got like 2 speeds. So if I press the button a bit deeper, it's going twice the speed. And then I have like a ultra slow speed if it's like just like for the really last bit. So at the moment we have like 4 buttons available, but we're just using 3 buttons with like, and they have like different depths. So it's like 1 and then sensors, yes. So there was one challenge with this machine. If we are running at a relatively high speed, the machine, it takes some time to stop down because there's actually no active brake in there. It's just like if it's breaking down, there will be a current inducted in the motor, which is then cannot go back to the grid because the frequency converter cannot do this. Very big machines can do this, so they can absorb the energy and bring it back to the grid. But for small machines, that is not possible. And like this, we are limited how fast we can brake. We might get like another braking resistor to dissipate this energy which is being generated, but for now we don't have it. So it's getting dangerous if you're getting to the end of the machine, because it's like insanely strong. It can go up to 20 tons. So if we say go backwards and it's hitting the end of the machine, it's 20 tons pushing into the machine. It's like destroying itself basically. So the manufacturer says like some limits. So as soon as we are getting like close with this end to this point, 2 centimeters before this, there's like a sensor saying period at the end, and then we wired it up, or it's like supposed to be wired up. That's like an emergency shut off, so like the machine is getting shut off.
Is this inductive or is this mechanical?
Inductive sensor. And the problem is like if you had high speed, it's still running like for maybe more than 2 centimeters, more like 3 or 4 centimeters. So if you're high speed, we would like crash into it, and I asked the company and said like, even if we're like not having actively force on it, even if it's just like the free running mass going into there, it's anyway able to just clamp up that much that you could not undo it anymore, and it's like basically destroyed.
Can you get the inductive sensors to another place? To just
that was like the first option, to have like a bit of a more safety margin, but that's not possible. We would need to drill like the inductive sensors are like at the end. You see like the 2 sensors here. There's like one in the front and one on the back. They have like the small light on. As soon as you go with the end of the shaft into there, it's like turning off the lights basically, and signalizing that's there. We could have drilled like new holes. The problem if you're drilling new holes, there's like some small metal fibers falling in the back, and it's like ending up on the shaft, and which is like then just like destroying it over time most likely. So it would be really difficult to do this like once it's assembled like this to change the position.
How about getting another sensor?
No, we have other sensors.
So we have so the solution of this whole topic is if you're running it like so the speed we can run is like up to roughly a bit about over 1,000 millimeters per minute. So about a meter per minute we can run the machine. If you're at this speed, we have like 4 or 5 centimeters of braking distance. If we had like a 350 millimeters per minute, which is our normal testing speed, which we also just detected the test right now, we have like about 0.5 centimeter, so 5 millimeters of braking distance. So that's like enough basically to brake safely, because you have like the 2 centimeter distance. So what we did now, we just like installed like some 2 more sensors, which you can see is one sensor. The other one is somewhere back here, somewhere here. So if you're getting like 10 centimeter close to the end, we're limiting the maximum speed. So it's almost like I can show it. It's like just taking a little bit of a moment. So I'm running now at 700 millimeters per minute. That's like what we have at the fast speed. We could go faster. It's just like for now we limited like the maximum speed here, and we're getting closer. And I'm still pushing the button, and now it's like slowing down. So we're just limiting like the maximum speed here. And if I would go now further, like this marking is showing like the maximum how far we can go, then the other sensor is getting triggered.
Hopefully.
Which is about 2 centimeters, 1, 0. And now you can see here back there, it's like basically 0.5 centimeter of overlapping. And now I can only go backwards. Once I think I need to reset it. Yes, reset, and now I can go backwards. I think we tried to do this software-wise that it's resetting automatically. I'm not sure anymore why. You need to look at it. So that's how it works. Problem about resetting is once the frequency converter is like restarting, it's like taking a moment, and then it's like being quite loud for one minute until it's being quiet again. So yeah. Otherwise, what we see here is like there's like a polycarbonate plate, which is basically there to protect like this this track, because if anything is breaking and metal is destroying this aluminium track, we get like maybe some scratches in there, and then it's fucking up the sledge, or it's not running nicely anymore. So we have like here this protection shield over it, which hopefully protects it well enough.
What about protecting the screw?
The screw, yes, that's like now the other thing we need to think about it, because right now the screw is like here free, and one annoying part is if you touch it, you have like oily hands.
You can buy some textile or rubber ones.
Yeah, we need to see what is like the best option, how to get something above it to not be able to touch it. And I think the more critical part is like anything is going in. Yes, you need to see. But it needs to work in such a way because this one is going up to 2 centimeters close to here, so it needs to be really small. Yes. If it's like too flexible, I'm afraid that if the textile is getting into here and getting sucked in, then I have big problems. So we need to see exactly what is the best solution. We have like this distance here in the front where it could get folded up. So it's just like one thing we need to do. So it's like not super urgent, but like medium terms we want to have like a protection over it. Yeah. Otherwise, one more thing we have is a vacuum cleaner back here, which because we heard from some experiences that there is like a lot of dust inside ropes, especially if you're testing old climbing ropes. If you look at them, they're sometimes quite early black, which means there's like a lot of metal dust in these ropes, and if you destroy them, then they start like, especially the aluminum, which is dangerous, is flying around. And if you do a lot of tests all your life long, you breathe in this aluminum dust, that's like really not healthy. And so our idea is having like a asbestos vacuum cleaner, so with like a really good filter back there, industry grade. And we want to have like a pipe on top of here, which is like then automatically getting activated. That is like just like sucking in all of the dust, or also like all the nylon fibers or all the fibers that they're not flying around and you're getting into your lungs. So that's like the idea, which we need to still implement and see how well is it working. Yes. Any questions at this point?
Practice cyclic mode.
Yes, exactly. Like the modes which we want to use to use this machine. Like I think it was in the live stream or the first test which we did. Or
yes, it was,
maybe
but
not people saw it.
people didn't see it.
It's like basically a normal destructive test. So we have here the 2 whales to test webbing. So it's like a special web lock, which is a really big diverter. So it should not weaken any webbing. And therefore we just like take the webbing and we just press the button, destructive testing, which is like just pulling until it breaks. We have like an upper limit defined. So if you know we want to break a webbing, which is holding 30 kilonewton, we can put it like 40 kilonewton, and if anything is going wrong, basically, and we're ending up at 4 kilonewton, the machine would also stop. It's like a bit of an emergency, that in case anything is catching or something is going wrong, and we know these numbers are way higher than we expect, the machine is stopping also automatically. And I think with the same method, we can also hold at some point, so we can also just go to 20 kilonewton basically, stay there for a while, and go backwards again.
What's the cycle per second or per minute that you can reach with this?
For cyclic loading. Yes. So second test we can do is cyclic loading, and therefore we have like the software which we still need to optimize a little bit to be more precise, because the difficult part about cyclic loading is you cannot just tell the machine go to 6 kilonewton and stop, because as I said, it takes some time to break down, and if you have like 5 millimeter of distance to break down, if you have like a static device like an aluminum carabiner, it will just, the force going up and is breaking there. So if you tell 6 kilonewton, it starts breaking at 6 kilonewton, but then getting it destroyed. So we need to know when we need to start to break to end up at 6 kilonewton, and that's a little bit of like an optimization problem, which we are about to solve and find like that we have done something which is like working more or less fine, but it's still not precise enough, and sometimes there are some bugs in there. So we need to solve this like software-wise, and and then we can cyclic load it. Therefore, we have also like to increase like the cycling speed, because that's like what we want to do. We don't want to have like a cycle taking 10 seconds, because otherwise, if you want to do 100,000 cycles, it takes more than a week. I'm not sure exactly. I think more like 3 weeks or so to get like 100,000 cycles. So that's a bit too long. So we would like to be relatively fast. I think as far as I know, it's like 1 hertz, like cycle per second. You end up like with like for 100,000.
So
I think it's like a bit less than a day, or
yeah, something around a day.
Yeah, around a day. So that would be our aim, to get like cyclic loading test of 100,000 cycles within a day, maybe also 2 days or a weekend. What we need to do for this is like reducing the stretch, because the speed of the machine is limited, so we cannot go fast at a certain point. But what we can try to do is like limiting the stretch, so we don't need to go far for a cycle. If you're managing to have, all we need is like 5 millimeter forwards and backwards, we can have like quite a lot of cycles per minute. So if you're getting like really down to 1 cycle per second, that's like the question. But it would be nice to go to a cycle for 2 seconds for a cycle or so. Like this, I think we could work efficiently enough, and therefore we need to minimize the stretch. Therefore, we have like a chain.
Sounds like a cow.
Yes, a cowbell. That's the other one. So we would install a chain, 13 millimeters chain, which has like basically no stretch at all, and can then have like our device in there. I think the main aim is like really cycling metal components. It's like the question like how interesting is like webbing cycling, because so far I didn't hear that this is like really interesting. It's like also there's a limitation. If you do like high cycles in webbing, it starts getting hot and melting, and then you need to anyway reduce like the speed.
And web logs and camera rigs, they have abrasion.
Yeah, so there is some potential things, but anyway we cannot go too fast on cyclic loading webbing. So mainly we will web logs is the most interesting point to test, and I think in the slackliner thing, and maybe also leash rings or something like this, and they have like low stretch, so you should be able to get like quite a high fast speed, because there's almost no stretch in the whole system, so we don't need to move far. And we can, with this machine, we can also move relatively precisely. We can move like super slow and super precise, and like this, we should be fine to hit the numbers relatively correctly.
From the experience that I have with the lab that we work with, they had an issue about 2 or 3 years ago. That's why I asked if the load cell is calibrated. They had an issue that their machine went out of calibration after some time, and they had to recalibrate. And what I learned from them is at this year, that from then on, they have the guy from the company, it's Siebert, they are in Ulm in Germany. I think they have them in their site every 6 months or every 12 months to recalibrate the machine. So what we've seen is when it was not calibrated correctly, the results were off by like 20-ish%. Okay. So this is an important issue that I think must be addressed in a regular frequency.
Yes, I think when I was back in UK, we also get it calibrated, our machine, and there was also like the thing as like we needed to do it once per year to be, I don't know, able to do a certain amount of certain kind of tests. So there's like some calibration which needs to be done if you want to have like tests or results which are like reliable. I don't know what is exactly the plan. I think we have it like really new, so I guess it's calibrated correctly, but I'm not really up to date what is exactly the situation with the load cell. And I guess like easy solution is also like short term to just put once in a while in a line scale and at least go to 20 kilonewton or something like this, and see if this is like fitting in this range.
The line scale has the same issue. I just send in my line scales like every 6 or 12 months to Andy, because they go off, like if you have regular banks on them on the side. We had this test in Bartels with the helicopter tests, and we had 2 line scales that were recalibrated several months before. We had the 2 line scales going different. One showed 5 kilonewton and the other showed 6.5 or something like this. It went off like way off. So a line scale is not a calibration instrument.
But yeah, I mean, getting like another load cell which you know is calibrated, or however you're doing this, we need to see how we're doing this exactly.
Are you controlling like temperature? Because temperature will have an influence on the load cell.
On the load cell, I think down here we have the advantage that it's like quite constant temperature, even winter and summer. I think it should not make a huge difference here because there's no direct sunlight. We're like in the basement, so it should stay relatively constant here. So that's like, I guess, a good advantage. It's not like that we are above summer, that's like heating up like 40 degrees in the summer. Walter?
But the question is, what's the accuracy you need? And what you're talking about temperature, I think it's not really relevant for that what you need. If you want to compare your device with my device and with UIAA, then it has to be accurate.
Yeah.
But plus minus something you have to decide.
Also, what we have to say, the load cell is able to be,
configured,
calibrated
yeah.
For temperature.
Yeah.
So you can, this load cell is able to do it and produce, depends on which temperature it has to produce the correct results.
0.2 is normal or case.
And like if you do cyclic loading, how long will the spindle like tolerate this? I mean, going back and forth in basically more or less for metal parts the same position.
Yeah.
I was asking the company and they said like overall the spindles are done. They are not made for brake testing at all. It's like basically, yeah, we are testing this. I was talking to them and I said it should work. They don't see any problem with this. And I was asking them about this, but what they are made for is actually assembling lines where it's going the whole day in and out, in and out, in and out. And also like 1 meter, so I think also already quite long one. And a lot of situations like not such much distance where they're moving like this heavy loads around. So it's like not something special that this spindle is going in and out the whole day with high loads. So they said like they don't see any problem, and then asked them like maybe it makes sense to, if I do a new test, I just slightly change the position that is not running always on the same point. And they said, yeah, that might make sense, but they were not even like saying like, yes, do this for sure. It was just like, yeah, you can do this, but they don't see any big problem. What they said, if you're doing a lot of tests, you should run out this at some point like all the way in, that like the fat and the lubricant can get distributed like evenly again, and also check if there's still enough lubricant on it, or that we need to redo it. But that's like the only thing that this could get moved out of the way at a certain point and dissipate. So it's sometimes good to go all the way in and out again to reset everything. Yes?
And do you know about the play, like in your setup? How much mechanical play do you have? Like, especially if you try to do like cycles, you would need to know either you would need a controller that tries to get rid of this, or you would need to exactly know the play you're dealing with.
I mean, the system we have right now, we don't need to have the precise play, because what our approach was, which was like coding-wise not working 100% efficient now, but we try to solve this. Each cycle, so we are aiming for 6, let's say 2 to 6 kilonewton we're aiming for. Initially we're saying, okay, start at braking at 4.5 kilonewton, that we guess we are arriving at 6 kilonewton. We actually measure this value where we are having like this maximum load, and we're ending up at 6.5 kilonewton. We know next cycle we are starting braking earlier. We're not braking at like 4.5 kilonewton, but at 4 kilonewton already. We're starting braking.
Yeah, what you're describing is the definition of a controller, but like how do you set it up?
Oh, in software.
Okay,
the software is like
only just
the software is measuring basically like the software is controlling everything. So this handheld device is like I can control it without the computer, but the load cell is connected to the computer, and also like the whole testing protocol is like on the computer. So that's like independent, and so the computer needs to run, and the computer's non-stop recalculating and readjusting like the range that we are ending up at this point. So that's like
play doesn't even play a role.
No. Play doesn't matter at all. So there might getting more into the system at some point. I mean, also like the carabiner can start failing or deforming or so. So there will be more play in the system at some point, but the software should adjust it accordingly to still be in the same range. So that's like what we want to do. And it was also like one reason why we go for this system is because it we thought it's already relatively straightforward to do the coding for this. And with Simon, who can do the coding, we have like the possibility to write all the software ourselves. So we are completely independent of any companies. So we can do everything what we want to do. Just our limitations is like the question, but we are not independent on any software from another company, which they give us and saying, okay, that's what you can do, and not more. If we're running in any problems, we have like the full freedom to change the software accordingly to our needs. And I think that's like a really big advantage, because I saw so many softwares where I think like it would be so nice to just have like this small change, and then you talk to them like, nah, we cannot do this, you cannot do this, we cannot give you the open source thing, and you're there sitting there and like saying, yeah.
So you're basically adjusting your controller for every part that you measure. to make sure that it doesn't like freak out and destroy your cycles.
Yes, I mean each cycle is being controlled basically.
No, but like what I mean is like I have a background in helicopter blade testing, and the thing is like if your blade that you're testing is bigger, you also need to adjust the values your controller is controlling your setup with, because otherwise it might actually like get into like destructive interference and like increase the load you're actually putting on your part in every cycle and just even destroy the machine. So you need to take pay close attention to how the controller is set up if you do cyclic testing, because if you can't just go with one set of variables for every test, because it depends on the stiffness of the part that you're actually testing.
We had like yesterday, like the problem we broke, like the one carabiner, which we're not planning to break, because exactly of this problem. We like setting up a relatively fast speed test, and then we had like the turning point set not low enough, so we are running, and the machine was basically starting to break, but by far not fast enough, so the load was going up and destroying the carabiner really fast. We wanted to cyclic loading, we were just breaking it at 20 kilonewton because we were not setting it up accordingly. So we need to see. One idea is like it's really like about the coding, how we're doing this. One idea is like to just get like one time relatively slow running test to see, okay, we are going from 2 to 6 kilonewton really slow, that we are actually really managing to stop in time, and then we have like an estimation of like how much is the path, how far is it going, and from there on we can do the first calculations of like where are the turning points most likely, and from there on it should work then for all of the materials independently. But yeah,
it will probably not, but I would just like advise to set like limits, like separate limits.
Yes.
Whenever like your controller cycle goes above like a certain correction that it wants to apply to your forces, you should immediately stop.
Yes.
Otherwise, you will just end up incapacitated.
I mean, that's definitely something we need to look into it, and we can set up also like all of these limits like by hand right now. So that's the transition. We can have like the flexibility, and we can learn out of this. I think there's no risk of destroying the machine because we don't plan to cyclic load something which is going up to 20 tons. So everything which we are cyclic loading in there should break before the machine. So that's what we are planning to do most likely.
There's maybe another option would be if you want to cyclic load the carabiner, you put in the system you put a piece of nylon webbing, which you know is going to stretch more, have more.
I think that's not the. I mean, what we are trying to do is getting all the stretch out of the system, and then adding some stretch again. Then we can just run the test slower. So that's like the same, coming back to the same result. If we are running the normal test at like 300 millimeter per minute, we can just go down to 30 millimeter per minute, and then we are for sure not destroying anything because we're going so slow.
According to the theory, for metal parts, the frequency doesn't play a role. Like according to Worb theory, which is like the most important theory on like cyclic loading of metals, the frequency at which you're testing is not important at all. So you can just go slower anyways.
We can go slower. It's not.
It just
takes more time. So what we want to do is like having like a cycle as fast as possible, and that means we need to have like as less stretch as possible and run the machine as fast as possible. So that makes it for us that the challenge for the machine to, if you want to have like 1 cycle per second, it needs to speed up and slow down to the breaking point in half a second. So we have like really small time there, changing it again and around. And we need to see, that's like, we just need to test now, there's different approaches. We could have like this point that we reach 4 kilonewton and then start braking, or we also can calculate from the first initial pull, how much distance needs to be done between 2 and 6 kilonewton, have like this distance, and then having like, calculating saying, okay, 1 for like that many seconds, because we know the speed of the machine, we know the acceleration ramp and the braking ramp. And from there on, we can calculate in theory how long it needs to run, and we can enter like then the seconds, 1 for so many seconds, and then brake. And like this, I think we can maybe be more precise, and maybe it's like not as affected by like some bugs in the programming and the coding. But that's all like the things we need to figure out, and it should technically be possible. It's just like seeing where are the weak points of the coding and how can we do it as precise as we want. And then the question is also like how precise do we really need to be exactly. If you want to aim for 2 to 6 kilonewton, and the upper limit we are staying always in the range between 5 and 7 kilonewton, then most likely it's still like a good result out of there. And yeah, it's like a best reflective thing. It's like not super precise testing. It's like something we get a good idea what happens over cyclic loading with different materials. Yeah. Okay.
Cool. Any questions from online towards Yoshi? I cannot see anybody holding up their hand, so I think if not, then I think we will conclude the online session here with this last presentation of the ISA safety event. Thanks a lot, Yoshi. Yeah. So for the people on site, we will stay here a little bit and break test some stuff. Let's see, maybe we'll set up a test for you guys online as well and then live stream it. So if you want to really see one, you can stay in the chat and I'll open the live stream again once we have everything set up. Give us a couple minutes for that. If not, thanks a lot for joining the 8th ISA safety event. Hope you had a good time. So we basically recorded almost everything here and we'll add it online at a later point of time. So thanks everyone for joining. For those who want to see some tests, wait a couple minutes for us to set it up. Just stay in the chat. For everybody else, goodbye and thanks for joining. Bye-bye. Ciao, ciao.
Bye-bye, everyone.
Bye-bye.
you.